Good morning, everyone. Unfortunately, I'm not going to be in school today, so I want to try to work through our notes on angles of elevation and depression with a video, and I'm also going to provide you guys with an answer key that I'm borrowing from Mr. Meenan. I apologize, I know this is not perfect, but we can always fix the missing pieces on Tuesday. All right, so let's dive in here. Uh, I'd ask you guys to just kind of work your way through these notes as I talk through them. There's some things that I'm going to do my best to work on and write in as we go. And again, like I said, if there's anything unclear, we can fix it on Monday. Excuse me, Tuesday. So the last new topic that we're dealing with in this unit is angles of elevation and depression, and those are basically exactly what they seem. An angle of elevation is an angle formed basically by looking up, and an angle of depression is one formed by looking down. Now, the important thing to note here is that these angles are formed with the horizontal. We can think about that as, the flat surface. You can see in the diagram here, these dotted lines would be our horizontal. All right, so just like you would think, angle of elevation is going to be looking up, angle of depression looking down. Now, we've done some work this year with parallel lines, and both of these horizontal dotted lines in this diagram, you can see are parallel lines. Well, if I have parallel lines, these two angles, this angle of depression and angle of elevation, are identical. These are alternate interior angles. So we can use this idea to effectively treat an angle of depression and elevation as the exact same quantity regardless of the problem. All right, so before we get into some specific problems, let's take a look at this diagram. And what you can see on the right, there's a man looking up at a tree and with some different sight lines. And what we are meant to do here is to figure out which one is which. Well, if I look at angle 1, I would interpret that as the angle from the top of the tree down to this man. Well, if we're moving down, that's an angle of depression. And angle 2, I would say, is the angle formed from the horizontal up to the top of the tree. So if we're going up, angle 2 would have to be an angle of elevation. Uh, you know, I'm trying to do my best here drawing in Word, so excuse the poor penmanship, please. All right, so sorry about that. If we look down at a specific example, this is mostly what we will be dealing with when it comes to angles of elevation. Ultimately, what we are trying to do is we are trying to use the word problem and information given to set up a triangle that we can find a missing either angle or side. So let's look at this example. In number 3, you guys will have to sketch in this diagram, and what I'll do is I'll explain how I created this. The Seattle Space Needle casts a 67-meter shadow. We know that the shadow should be on the ground, so I have labeled 67 on the bottom of this right triangle. The angle of elevation from the tip of the shadow to the top of the Space Needle, right, basically from the shadow up to the top of our needle here, is a 70-degree angle, as you can see we have labeled. They want us to figure out how tall the Space Needle is, so we have two pieces of our three. We are going to use our SOHCAHTOA approach to solving this right triangle. So over here on the left, you can see how we would set up and solve. We would use the tangent function because we have our opposite side here and our adjacent side that we are working with. So we say that the tangent of 70 equals h over 67, and we can multiply that by 67, and we will find the height of the Space Needle to be 67 times the tangent of 70. If we plug that into our calculator, we get about 144 meters. I'm having a hard time with my technology here, so um, I'll trust you guys to use the answer key and your calculator to find that exact value. Let's look at a couple more. If we turn to page 2 here, here in this problem, they tell us we have an ice climber, standing at the edge of a crevasse that is 115 feet wide. The angle of depression from the edge to the bottom of the opposite side is 52 degrees. So that is all the information have been given to set up my diagram. We know that the distance across the crevasse is 115 feet, and the angle of depression, right, from the horizontal going down is 52 degrees. So we've created another right triangle problem, another SOHCAHTOA problem. Oh, excuse me. All right, let's see if we can type this out now. So what I have here, I have a 52-degree angle, and I have the opposite is unknown, and the adjacent is 115. So again, I'm going to use the tangent. The tangent of our angle is 52 degrees, and that will equal x divided by 115. Well, just like the last problem, we are going to now multiply by 115. So x will equal 115 times the tangent of 52. And again, sorry, I typed 114. That should be 115. And you can plug that directly into your calculator to find that height. The last problem here is a little bit more complicated, so please stick with me and try to follow the logic here. In number 5, we have an observer in a lighthouse that is 69 feet above the water. He sights 2 different boats in the water in front of him. The angle of depression to the nearest boat is 48 and the other boat is 22. And we are meant to find the distance between the 2 boats. So what I've done is I've set up 2 separate triangles where I'm going to find the distance to the first boat and the distance to the second boat. So to find x here, what I would do is set up my diagram. Now they tell us we have an angle of depression. That angle of depression is made with the horizontal. In other words, it's not really part of our right triangle. So what I like to do is I like to rewrite that angle of depression as an angle of elevation using that property of alternate interior angles. Well, now that I have this 48 degrees inside my triangle, this is going to be the same as any other SOHCAHTOA problem. So I would set this one up to find x with, again, tangent. So tangent, I got to type here. All right, so the tangent of 48 degrees would equal, sorry, let me get that out of there. All right, so the tangent of 48 degrees would be 69 divided by x. Why is this thing still there? All right, that's better. And then what we would do to finish this is that x would equal 69 divided by the tangent of 48. Our work on the other triangle is going to be almost identical. We can even, copy and paste it. Let's see. Oh, not very easily. Not my day with technology, guys. I appreciate you hanging in. So what we would do on this other triangle, where the angle of depression was 22 degrees, well, we're still going to use the tangent. In this case, we're going to use of 22, and that will equal 69 divided by what I've what I've called y. What y is going to represent here is the distance to the further boat. So when we solve for y will equal 69 divided by the tangent of 22. Now, in the problem, they wanted us to find the distance between the 2 boats. So the last step here, and I'll leave this to you guys, and again with the answer key, the last step here is going to be to subtract y from x. All right, so the x is closer, y is further away. So as a final step here, whatever we get for y, final answer will be y minus x. Right, y is going to be a longer distance, and the distance between the boats will be y minus x. Hopefully you guys have that answer key nearby and you can finish up this problem there. Thanks, everybody.